again, we're going to use the information from the previous lesson, finding the opposite hypotenuse and adjacent sides of a triangle, and applying it to the 6 trig functions that are most common. Well, 6 trig functions, whatever you want to say. So I've got both my examples here from the previous lesson. And what I'm going to talk about is I'm going to talk about the sine, the cosine, the secant, the cosecant, the tangent, and the cotangent. Pretty interesting in their own right. 6 trig functions. I'm not going to spell them out, but what I'm going to do is I'm going to abbreviate, because that's what your book would do anyways, and most people just abbreviate. They don't spell out secant, they just spell out SEC. So here we go. One of the trig functions is called the sine. It's S-I-N-E, but it's abbreviated as S-I-N. And basically what that states is this: the sine of an angle, and if you know the angle, you actually substitute it in. I don't know what this is, it's just theta. That's all. If it's at 60, then you put sine of 60. But since it doesn't put anything in, don't worry about it. Equals opposite, which I'm going to put for O, because I'm not going to spell out opposite, over the hypotenuse. And yeah, for those of you who are watching this and say, oh, so katoa, why don't you just teach it like that? Because I don't want to teach it like that yet. I don't want to. Okay. The other one of the trigonometric functions, pardon me, is the cosine. Spelled with sine, except there's a co in front of it. But we only abbreviate it as COS. And basically what that says is the cosine of an angle equals the adjacent over the hypotenuse. Next one we have is the secant of an angle. And we have the cosecant of an angle. What's really interesting is that the cosecant is the hypotenuse over the opposite. And I don't memorize that. I look at these really quickly in order to ascertain that information. And the secant of an angle is equal to h over a, or the hypotenuse divided by the adjacent. The last 2 trig functions that we're going to be working with are the tangent of an angle and the cotangent of an angle. The tangent is opposite over adjacent, and the cotangent is adjacent over opposite. So there you go, your 6 trig functions. Sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, secant of theta equals hypotenuse over adjacent, cosecant of theta equals hypotenuse over opposite, tangent of theta equaling opposite over adjacent, cotangent of theta equaling adjacent over hypotenuse. Pretty cool. Nothing terrible, but whatever the case. Now, what's really interesting is, the reason why I wrote it like this, and you probably don't learn it like this, is this. Sine and cosine are something called cofunctions. There's actually something really cool about that, and I'll explain it later. If I explain it now, it just won't make, well, I could, but it just won't make as much sense as it could. Secant and cosecant are cofunctions. There's actually a co in front of the secant. And tangent and cotangent are something called cofunctions as well, which actually brings something to mind. When you look at the graphs of tangent, secant, and sine, which we'll look at later, there are 3 very distinct graphs. The way that schools teach it is sine, cosine, and tangent, but sine and cosine are very similar in terms of that, so it kind of sparks up a debate that maybe the functions that people were using were sine, secant, and tangent, and they came up with the cofunctions afterwards. But you know, that's debatable, because actually you can always talk about reciprocals and that kind of stuff. But I think that's pretty interesting. We'll talk about cofunctions and we'll talk about that later. But I do want to bring this up. Really cool. Sine and cosecant are reciprocals of each other, not inverses. Lots of people get that confused. They're not inverses. And when we talk about inverses, I'll explain the difference between the 2. They're reciprocals of each other. Let me say it again. Not inverses of each other. Basically, all that means is this. O over H, when I flip it, is H over O. They're reciprocals of each other. Cosine and secant are reciprocals of each other. Not inverses. Reciprocals. And there's a huge difference. And tangent and cotangent are reciprocals of each other. Somebody says, oh no, this is the no, it is not the inverse. These are not inverses, these are not inverses, these are not inverses. These are reciprocals, and these are reciprocals of each other. Anyways, Let's do an example, and we can pick one of the two. I'm not going to sit there and do both, but if we can either pick the first triangle or the second triangle in order to do this. And I'm going to say this right now. I want to go ahead and I want to do the first triangle of all these functions. You can sit there and you can do the second triangle of all these functions afterwards, and the answers do vary. I'm debating whether I should or not, but I don't want to do it right now. So the sine of theta equals opposite over hypotenuse. And we're doing this triangle right here. Ignore the second one, we're doing the first one. So the opposite is 4 over hypotenuse, which is 5. So the sine theta equals 4 over 5. That's it. I wouldn't write 4 over 5, I'd write sine of theta equals 4 over 5. I would write it as sine theta equals 4 over 5. Many people get in the habit of just writing 4/5. That's actually wrong, because when we end up doing inverse functions, you have to actually figure out what this is. I don't know what it is right now, but you have to figure it out later. So get in the habit of writing it like this. Sine of theta equals 4/5, not just 4/5. Same thing, cosine of theta equals 3/5, and so on and so forth. So the adjacent here is 3, over the hypotenuse is 5. I don't really have to do much work to it. If I know the sine is 4 over 5, then the cosecant, which is the reciprocal, is 5 over 4. This is the reciprocal of this. So 3 over 5, 5 over 3. I got to figure out the tangent, which is the opposite over the adjacent, or tangent of theta, which equals opposite over adjacent. It's 4/3. That's the reciprocal, which is 3/4. Pretty cool. Pretty fascinating. I'll go ahead and show this anyways. I'm going to erase the second triangle because you're going to see it in a classroom anyways, especially in the United States. I don't know about overseas so much. If you see it, I don't remember. Well, actually I did, but nobody really understood it the same way. I think it's like some kind of American thing, but it's not. Anyways, I'm going to go ahead and erase this really quickly. And here's a little mnemonic device that you can play if you want to. It's pretty cool. It's called SOHCAHTOA. And actually, if you memorize it, then it's not so bad. Basically, that means that you write it out SOHCAHTOA. That means the sine is opposite over hypotenuse, which it is. The cosine is adjacent over hypotenuse, which it is. And the tangent is opposite over adjacent, which it is. And then somebody says, is there a, is there a trick for secant, cosecant, cotangent? Yeah, it's called memorization. Cotangent and tangent are reciprocals. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. I talk about this every year, maybe 1 or 2 students out of 30 get it in that particular class. But I'll go ahead and give it a shot because maybe somebody will get it. How can you memorize reciprocal functions? Well, tangent and cotangent go together because they sound alike. If I'm taking the reciprocal of sine, it means I'm switching the S to a C. So they're reciprocals. Nobody really buys that, but sometimes people memorize it. Like, oh, so sine and cosecant are reciprocals because when you're flipping it, the S turns to a C. I'm like, well, not really, but yeah. I mean, yes, but not really. And the reciprocal of cosine, when I flip it, when I take the reciprocal of it, is turning the C to an S. So yeah, I could do that too. Well, not really, but if that helps. And it helped me. That's how I memorized it, actually. So pretty cool. That's pretty much it there. I want to do some more lessons, obviously, with that, but this is a good basic before we get to more complex ideas, which are really cool. I might expound on this just a little bit, but we'll see how it goes. But for right now, have a good day. Goodbye.